Of Valorum's channel. Today we are going to look at a delicate point and a topic on mathematics for economics 1. That is equation system. Equation. Okay, so quickly let's go through what an equation is. We'll talk about equation when you have an expression that is actually connected by an equal sign. It tends to be an equation. Okay, so under this topic we look at theory, economic model, components of economic model. Then we look at equation systems and then functions. There are lots, but today we will tackle this. Subsequently, we will look at simultaneous equations, how to solve two variables simultaneous equation and other things. So when we talk about economic theory is simply an abstraction from reality. You are abstracting from reality. Okay, so what we are saying here is that the real world is actually complex. Okay, and because it is complex, economists tend to represent the complexities of this real world in a simplified form. So when we are saying economic theory, it just explains or it simplifies what pertains to the real world situation. Okay, so what is complex in the real world, it simplifies it. Okay, so when we talk about the theory of demand, so we are saying that demand is something that talks about the purchasing power of the people, the willingness and then the ability of people to buy at a point in time. So if we are talking about a theory of demand, we are looking at how people buy. Okay, so something that has been stipulated to actually explain and then simplify the purchasing ability of the people. That is about theory. And then when we talk about economic model is a deliberate and then simplified analytical framework that is used to explain and understand the complexities of the real world. So the real world that is complex, what helps to explain and understand these complexities of the real world is an economic model. Okay, an economic model has some components. So the components of economic model includes we have a variable, we have the constant, we have parameters, and then maybe we talk about coefficients. So when we talk about a variable being a component of economic model, a variable. So when we look at a variable, we are saying a variable is anything whose value continually changes. Anything it doesn't have a fixed value. The values keep on changing. It takes on different values at different times. In economics, we consider two types of variables. We look at endogenous variables and then exogenous variables. So endogenous variables and exogenous variables. When we talk about endogenous variables, they are also called dependent variables. And then the exogenous variables are called independent or predetermined variables. The endogenous variables are the variables whose values are sought from the model in question. Okay, you can actually determine their values based on the model that is being given. Okay, and then the exogenous variable, when we look at the exogenous variables, they are values, they are the variables whose values are determined by forces that is external to the model. Okay, their values are determined by what? Forces that are external to the what? To the model. Okay, good. So an example of an endogenous variable can be a national income. Okay, we talk about national income. Okay, and then you look at your consumption function. You have consumption, your national income, and then an example of exogenous variable can be government expenditure. Okay, good. So now, apart from a variable, we may have another component of an economic model that is known as constant. So we are saying the constant is the opposite of a variable. So since variable changes, constants do not change. So a constant is anything whose value does not change in a given model. It doesn't change in a given model. So that is constant. So whenever a constant is attached to a variable, it becomes the coefficient of the what? The variable. So for example, let's say I have a variable x, okay, and then I add 2, which is a constant to the x. I have 2x. Now the 2 which is attached to the x becomes the coefficient of the variable x. Okay, so that is that. Now we have another important component which is called parameters. Very good. So when we talk about parameters are constants which tend to be variables. Okay, they are constant, which tend to be variables in a model. So for example, in an economic model, if I have something like this, if I have beta multiplied by y, okay, this beta is supposed to be some constant, but at this point it is acting as a variable. Okay, and then it is acting as a variable in the model. So whenever a constant acts as a variable in the model, it is called parametric constant, or it is called a constant. Okay, so quickly, these are the major components of an economic model. Let's quickly run through. Now let's look at an equation, the types of equation system. Okay, so with the types of equation system, we are going to look at a definitional equation. Okay, we will look at behavioral equations, and then we look at an identity, and then also we look at equilibrium condition. Okay, equilibrium, and then when we talk about an identity, identity is an expression which is true for all values of a given domain. Also, an expression which is true for all values of the variables in a given domain. So if I write this function, let's say let's say we are saying that our national income, which is y, is equal to c plus I. Okay, so this y is equal to c plus I is is an identity. Okay, it is an identity because we are saying whatever is at either side of the equation is the same. So we are saying that this y, which is representing income, can be the same as c plus I. So now I can say c plus I is the same as y, and then y is also the same as c plus I. That is an identity. Okay, out of identity, we can also look at definitional equation. Also, when we are saying a definitional equation sets up an identity between two alternate expressions which have the same value. So a definitional equation is just like having an identity. Okay, you are just defining the equation. Okay, so it sets up an identity between alternate expressions which have the same value. So at this point, we can say profit is equal to total revenue minus total cost. So this is a definitional equation. Okay, our profit is equal to total revenue minus our total cost. We can also say our total revenue minus total cost is profit. We are just defining profit in terms of its formula. Now let's look at a behavioral equation. When we talk about a behavioral equation, it captures the response of one variable as a result of a change in the value of other variables. Okay, so it looks at how other variables change when the value of other variables also change. So now if I have quantity demanded is equal to, let's say, let me say 5p minus 3. Let me say I have quantity is equal to 5p minus 3. So now we are saying the quantity here is a function of price. So how much will be the quantity depends on the price. So a change in the price will automatically affect the quantity that will be bought. So that is the behavioral. It captures the response of one variable as a result of a change in some other variables. That is the behavioral equation. Now let's look at another last part known as the equilibrium condition. So the equilibrium condition is very important when we want to actually establish an equilibrium between two items. And then we know that at equilibrium, we know savings is equal to investment. Our intended saving at equilibrium is equal to our intended investment. So our intended savings at equilibrium is equal to our intended investment. And then at equilibrium, our demand, so the quantity demanded, is equal to our quantity supply. Quantity demanded is equal to our quantity supply. So this is a delicate part of mathematics for economists. See, I want you to go through this, get to understand some of the concepts, and then this is going to help you in your further studies as you progress to do other topics in the study of economics or mathematics for economists. Thank you.